Good morning, guys. Can you hear my voice?
Good morning, sir.
Why others are not here? Only 4 are there. Okay, so we'll wait for 2 minutes, then we'll start our class. All right, so let us now start our class so that we will try to finish in time. In the previous classes, if you would have observed, we studied a brief introduction to operating systems in 3 parts. We tried to understand in the first class what are the hardware devices, what are the input-output devices, what are the storage devices. Then we tried to understand what is an operating system, what is the job of an operating system, what are the various managements that an operating system will look into, how operating system will start, like bootstrap programming or by loading into other kernel program, then other application programs, and so on and so forth. We try to understand what are the various briefly things that operating system does, like CPU scheduling or process management, memory management. A lot of things are handled by operating system. We try to look at it into very briefly in the previous classes. In-depth study, we'll try to study how the process management will happen, how the CPU management will happen, how the scheduling will happen, how the memory management will happen. All these things we'll study in detail in the subsequent classes. But as your course also says that along with operating system, we need to study data structures, which is also an important, because yesterday's class, I mean the previous class, we studied that a kernel will follow a certain data structure to make it efficient use of its operations, right? So as a part of that, we will try to understand what a data structure is. Today we will try to understand a brief definitions or statements. Through that, we will try to understand what is a data structure and what is algorithm. We will try to understand in today's class. Maybe in the next class, we will try to continue our discussion how we will try to carry forward with data structures and algorithms and various other concepts that are associated with it. Now, also this for your assignments that we are going to work on your assignments. Most of the assignments that are been asked to design on data structures. So once you are implementing in lab also, discussing these data structures will help you for in a very easy way to implement. Okay, so that is also another strategy that we will try to keep in our mind. So we will try to see what are the various data structures are there, what is the data structure, and what are the fundamentals that we need to learn before studying the data structures and algorithms. All in today's class we will see, and we will subsequently cover the rest of the topics in the remaining classes. Okay, so let us start. Today we'll try to understand what is a data structure and what is an algorithm. And so on and so forth. Okay, so if you have any doubts or any questions meanwhile, you can stop and ask me to repeat. I will repeat, and if I'm going too fast also, if it is not making sense or it's difficult for you to grasp, you can also interrupt me, ask me to go slow. We'll go slow and we will try to understand. Okay, so let us now try to understand what is a data. So a data is a value or a set of values. Okay, it could be either singular or a plural form. Both we refer that as a data only. For example, 29 is a data. 18/11/2021 is a data. ISBN 812340 followed by a 0 is a data. Pascal is a data. Dollar symbol is a data, and so on and so forth. Okay, so all the examples that we see here are some values or a different ways are represented in a different ways, right? So each value or a collection of such value we call that as a data. So data could be any value or a set of value. So when I say information, information is different than data. Okay, so the term information is used for data with its attributes. Means you have to define what is the data. When you are defining with some attribute, some parameter, then you can call that as an information. In other words, information or processed data. So when I say 29, anyone can imagine it could be age of a person, or it could be a date, 29th, or you can assume that 29 rupees. It could be any data. But when I say age of a person, I'm defining what is that 29 is. I'm making some meaningful meaning from this data. I'm processing the data through some information, through some meaning. Then we call that as a information. So information is a meaningful data or a processed data. So 29 could be age of a person. 18/11/2021 could be a date. ISBN could be a book number. Pascal could be a nickname or a programming language. A dollar sign. When I'm defining some attribute to the data, we call that as a information. Okay, so a meaningful data we call that as information, right? So a data is a simple set of values or value. So once you have data and information, you define a data type. Okay, data type is a term which refers to what kind of data that may appear in computation. So when you're trying to do some operations, we are going to define our type. What is the data type? For example, 34 is a numeric, which is an integer. Okay, it doesn't have any decimal values. So 18/11/2021 is a date, is a type of data that belongs to date. Okay, ISBN 81, it's also having alphabets, it's also having numeric, so we can call that is data type as alphanumeric. We have Pascal, it's a group of characters, it's a string, we can call that as a string. Dollar sign, you can call that as a graphics, or you can call that as a symbol, and so on and so forth. Okay, so when you are assigning what kind of a data that will appear in a computation, we say that it's a data type. Okay, is it clear?
Sir, if we are asked to give a definition, what should be the definition actually
For what?
for data type?
You can say simply it's a kind of data that may appear in computation.
Okay, sir.
So you have two data types. One is built-in data type and abstract data type. So built-in data type, when I say, every programming language will have their own set of data types that are built in. For example, you used C programming in your first year. You define whenever you are declaring a variable. This is my data type. When I'm declaring a variable a, b, or a x, y, you are defining which are the data types like int, float, character, double, enum, right? You could have observed that these are the data types that they are come across, that you are defining when you are using a value data, you are defining its type. And Pascal, when you are using a Pascal programming language, then you will use this kind of data type. So Pascal will have a different data. Pascal has a different data type called Boolean. Boolean will say that true or false or 0 or 1. So here we will use a simple integer value to take care of Boolean, but you have a different data type Boolean in Pascal programming language. Okay, in Java also you have a Boolean data type. So you are defining, there are inbuilt, the programming language will come with some inbuilt data type. They are called built-in data type. But is there any data type like this? Date, month, year? Is there any data type for this?
Okay.
So there is no data type in C programming. In C programming, there is no data type, but in other programming languages, there might be. You have to, we have to check that when we are learning some other programming languages, we will learn that. But when we are defining, when there is no data type, but we can define with our own programming language. We can write a program how to define the date. So January month has 31 days, February has 28 days. If it is not a leap year, if it is leap year, then 29 days. Then you can define each month number of days, how the after next day, the next day will start, date will start, date will come, date will count. Those applications you can write your own programming language. That is possible. Okay, so a programmer will write will create in his own set of logic how a date will work with its own data type. We call that as an abstract data type. Okay, so it is also called as user defined data type. When I am defining my own way of doing how my data type will work, we can call that as an abstract data type or user defined data type. Is it clear?
Yes, sir.
Right. So let us now go into data structures, the concept of data structures. Now, data structures, before defining, I'll define what is a data structure is in the next slide. But before that, let us try to understand the concept of data structure. Why data structure is important, why it is needed, why we are studying the data structure is because we have a real life data or user data which requires few tasks. Okay, the few tasks will, the main important tasks are, you have a data, how you are storing the data, okay, such a way that computer will understand it. Okay, the storage representation of a data, how we are storing the data in a way that computer will understand, user data in such a way that computer will understand should make sense. So computer will arrange your data one after another sequentially, or it will arrange randomly. If it is random, how random it is, like for example, your data will be stored one after another, like an array, or if it is, there is no space in between, will it store at the next place or available space, then it is not sequential. Then there are various ways you can store the data. You can store the data in place one after another, or you can place your data one above the another, like a stack, like rice bags, how you kept one above the another. How you are storing your data one above the another, or one after the another, or one behind the another, like a queue, one behind the other. You are based on all the address, you are making a link, like linked list, making a graph. Like if you see the Google map, A, B, C, D, you have 4 destinations. You can go to any destination by any destination. So each node can be represented as a, each city can be represented as a node, and the connectivity among the cities can be represented as link. Then your data structure will be a graph. Then you can define your own data structure like a tree. So how we are storing your data in a way that computer will understand is one of the biggest challenge or a task user data or real life data should address. The second is retrieval of the stored data. Okay, you stored like one way, like any logical way in a computer. Now when I want to access it, when I want to retrieve the data, the computer should be able to bring it to me as much as efficiently, correctly, accurately, and with less access time. Okay, so how we are storing in a computer should be retrieved in a such a way that user can understand is also another task. How we are storing the data, how we are retrieving your data is also matters. For example, when you are storing in an array and I want to take the fifth element, now I have to go 1, 2, 3, 4, 5, fifth position after that. Now when I want to, you are storing a stack, then I want to take the bottom element, then I have to remove all the above elements, then only I'll be able to go to the, I'll be able to access the fourth element or fifth element, right? Because you are placing one after another. If I have to take one element, I have to remove all the top of the elements. So you are retrieving of a stored data. How you are doing that is also matters. Then the third is transformation of user data. You are applying some operations on the user data. It can be transformed from one form to other form. For example, when I divide 2 by 3, you will get a real number 1.5, right? Is it correct?
0.677, sir.
Yeah, 0.667, right? That will be a real data. That will be a real data, right? So it's not, previously you have integer data, so you transformed into real data. Your data will transform. You take any application. For example, you store in a variable A. This is your income. My monthly salary is 10,000 and my total salary for a year is, say, you add 12 times 10 to the 12. So this is your income, and you say that your expenditure B is equal to 8,000 per month. Then you calculate 12 into what is the balance, then you calculate A minus B. You will have the what is the balance that you have. That could be your savings or that could be your rest of the balance. When you apply some operation on A and B, your data will change. Your data will change from one form to other form based on the operation you are applying. Then what happens to the storage, what happens to the retrieval, what happens to the updated value, all these things also we need to look into it. When you are talking about data, how data is stored, how it will be retrieved, how when an operation is happens on the data, what happens, what effect it will create, all these three things, the manipulation of the real data or user data will require all these three things. Okay, so these are the main tasks that we need to keep in our mind before defining data structures. Okay, does it make sense?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Now let us define what is a data structure. So for a given kind of a user data, its structure, when I say structure, it implies three important parameters. One is domain. The domain says that this is the range of value of the data may have. Okay, you cannot have infinity value. You cannot, computers are not capable of storing infinity values. So computer is capable of storing only finite values. That could be even large value, but it's a finite value. You have to have a finite value, right? So you have to define the set of range. When you say in your C programming, integer, the range of values is 4 bytes, you say that the maximum number of bits it can store is 2 to the power of 32, right? 4 bytes, 8 4s are 32. Yes, 2 to the power of 32. 0 to the power of 32 number of bits it can store. So what happens when I store one value after 2 to the power of 32? Your computer will not able to understand that value because you define the range in that value only, right? So every domain, when we are defining a structure of a data, you need to define the domain. What is the range of values that data may have? Sometimes we will use data object also in terms of in place of domain. Data object or domain both are same. So second parameter is function. We will define some set of operations which may be legally applied on the elements of the domain or the elements of the data object, right? So we will define what are the operations that we are going to carry out. We are going to divide or addition or multiplication or modulus. What operation we are going to define on the function, we will define, right? The set of operations that are legally allowed, we will define. Then the third is axioms, which are the rules. Okay, this is a set of rules with which the functions can be defined. Okay, the set of rules with which different operations belongs to F actually can be implemented. Okay, so this is F. This F is the function only. So let me change that. This may create some confusion. Okay, so belongs to F actually can be implemented. So this is how we will define a structure. So the concept of data structure carries a domain, a function, and axioms. Is this clear? What is a domain? What is a function? What is axioms?
Yes, sir.
So let us now define a data structure. So a data structure is a triplet with D with three parameters. It's a domain, a set of data object, and a function, the set of functions, F, the set of functions, and A, the set of rules to implement the functions. For example, when I say integer data type in C programming language, the structure includes the following type. So when I say D, there is a domain, there is a range, minus 32,165 to plus 32,165. There is a range, right? For integer in C programming, you cannot have beyond some range is there. When you say 2 bytes, when you say 4 bytes, there is a range defined. Likewise, there is the operations. The functions legally you can apply on the integers are addition, subtraction, multiplication, division, and modulus. What are the rules? The rules, the axioms are the set of binary arithmetic operation to perform. So plus is an addition, minus is a subtraction, division, multiplication, and modulo operations are whatever you are trying to do, you can carry out on this data. So we are defining a programming language structure includes this. This is the domain, this is a function, this is the axiom. This is a strictly clear definition, but in simple words, if I have to simply explain what is a data structure. So a data structure is a set of procedures to define how we are storing the data, how we are retrieving the data, or how we are accessing the data, or how we are manipulating the data. Okay, so a data structure is a set of procedure to define, store, access, and manipulate the data. Or an organized collection of data is also called as data structure. How we are organized, like you are organizing in an array one after another. You are organizing your data in terms of a stack, one above the another. You are defining your data structure as a queue, one behind the another. You are defining a data structure like a graph or a tree. How an organized collection of data is also called as a data structure. Or the logical or a mathematical model of a particular organization of data is called as data structure. These are the various definitions, but more or less it gives the same meaning. Okay, so the logical means, so when I say tree, you are not having tree in your computer, you are not growing a tree in your computer. It is not literal meaning, it is logical meaning. Okay, how you are storing your data in your computer logically or mathematically in a particular order, in a particular organized way, is we define that as a data structure. So logical or mathematical model of a particular organization of data is called data structure. Okay, so this is a more meaningful definition. Okay, or this is the accurate definition. Data structure is a triplet DFA, and this is a more meaningful definition. Okay, so you can have a brief understanding what is a data structure is. Does it make sense?
Yes, sir.
Okay.
Excuse me,
So,
sir.
Yes.
Sir, what are axioms, sir? Please explain, sir. I could not get it, sir.
Axioms are set of rules. How we are defining your function. When I say plus, what does a plus do?
Sir, it adds two numbers.
So that I'm defining, right? It's a binary operation. A
Yes,
plus is adding.
Okay, sir.
So
Sir,
how
matlab,
you are defining, see, f is a function, the operations are there. How you are defining your operations is what actually the axioms are. See, axioms is a set of rules to implement the functions. Axioms is a set of rules to implement the function. Will work, how subtraction will work is the rules that you are going to carry out in axioms.
okay, sir.
If you don't understand, don't worry. We will discuss
matlab,
many examples in the
सर इसका मतलब बेसिकली यही हुआ ना कि सर हम पहले फंक्शन प्लस होगा और प्लस क्या काम कर रहा है वो ऑक्सियम बताएगा.
yes.
ओके सर, ठीक है सर.
Okay, so shall we go ahead?
यस सर.
Okay, so this is a simple understanding of data structures, simple definitions of data structures. Now, these are the various data structures that we have. The data structures can be categorized into linear data structure and a non-linear data structure, because the logically how your data been arranged can be defined in terms of linear and non-linear. So you can, so for example, array. You have an array, one after another. You know array how you are implementing. First element will be stored in 0th index. Second element will be stored in first index. Third element will be stored in second index. You are storing sequentially one after another. Likewise, you can say the strings. There is another data structure called stack. The stack will store a data one after another. You place one rise bag on the top of another rise bag. You keep another rise bag. One top of the other you keep placing in a linear way, right? One, it looks like a linear, one dimension. Likewise, you go to a queue in a bank or in anywhere, you will see that one data is placed behind. One person will come, the next person will come behind that person, the third person will come behind that. So one after another, you can place the logically way of arranging the data. Likewise, you have a linked list. You have a data, the next data address is stored in the previous link. The next data will be stored in the previous link, and the last data of the link is null. So you are making some sequential way of linear way of arranging the data. We call that as a linear. But you have non-linear data structures. In non-linear, the data will be not arranged in linear. For example, tree, you have a root, you have branches, you have left child, right child. Again, you have for the sub root, you have again left child, right child, and so on and so forth. Right? You have a graph. You can look at Google Map. You can say that say you have different cities, say Delhi, Mumbai, Calcutta, and Hyderabad or Chennai. You connect the cities like assume that these cities as a nodes. You connect the NH, the how to reach from Mumbai to Delhi or Delhi to Kolkata or Kolkata to Chennai. You define your link. That is a way. And you can directly go from Chennai to Delhi also, Chennai to Bangalore also, Chennai to Kolkata also. It's not one after another. You can go from any way. So when you're looking that kind of information, it will look like a graph. So it's not a linear, it's a non-linear. Logically, you can go from anywhere to any direction. There is no linear way of accessing. You have a non-linear, right? So the non-linear data structures, linear data structures, we will study in detail. But briefly, the data structures is divided into two categories. We are going to study all these data structures in the upcoming class. What are how we can define each data structure? What are the domain? What is the range? What are the set of operations that we can apply? How we are going to apply, define based on the rules? Everything we are going to look into it in our subsequent classes. But this is a brief introduction that these are the various kinds of data structures. You can arrange logically your data in terms of arrays, in terms of stack, in terms of queue, in terms of linked list, in terms of trees, in terms of graphs, and how we are storing, how we are accessing, how we are retrieving, how we are transforming when you're applying operations is all is all how we are defining each data structure is. Is it okay?
Yes, sir.
Yes, sir.
So how we are going to implement the data structures? The implementation of data structures where we need to worry about algorithms. Okay, that's where the algorithms will come into the picture. The implementation of data structure will carry out through algorithms. So let's now define what is an algorithm is. So algorithm is a set of specifies a procedure for solving a problem in finite number of steps. So you have a problem now. You have a problem. Now you have to find a solution to that problem, and and how you are defining that solution in finite number of steps. You cannot have infinity number of steps for a problem as a solution. Okay, you need solution in finite number of steps. Those steps could be like 5 or 10 or they are finite number of steps. So this is the procedure how to solve a problem in a finite number of steps is what an algorithm is. Computer scientists that when I say program, when I'm defining a program, it is nothing but algorithms and data. So in your first year C programming, you would have written a program to find a factorial for a given number, right? You have written a C programming how to find a
Yes, sir.
factorial for a given number.
Yes, sir.
Yes, sir.
So you can define you can define two ways. So for example, here the data is, for example, 4 is a data. 4 is a data that I want to find what is the factorial of the data. Then you are defining an algorithm saying that the value you can find for this data is the step 4 into 3 into 2 into 1. So you keep multiplying from the 4 value to reach to one value one at a time by decrementing it. Okay, so 4 into 3 into 2 into 1, you will multiply all these values, you will store in an array and print the result as a 24. Or you can do in another way also. The other way is you can start from 1, you multiply 1 with the result, then you multiply the result with 2, then increment the value 3 till you reach 4. You can start from 1 into 2 into 3 into 4, or you can start from 4 into 3 into 2 into 1. You can do reverse order also, and you can go in the incrementing order also. The algorithms, how you are defining your logic, both will give the same answer, but there are two ways you can define your algorithm. Okay, the logic, how you are defining. So with this, when I give you the data 5, then we'll multiply, the data will change and the n value will change. The algorithm, the logic is same. The algorithm, how we are defining the procedure to solve the problem, 5 into 4 into 3 into 2 into 1, or 1 into 2 into 3 into 4 into 5. Either way, the data is important, the data is not constant, but algorithms and data will help you to write a program. So you know how to write a logic, you give the data, you will get a program. Okay, so this is what to define a program. When I say the meaning, computer scientist Nicholas Gross says that when I have to define a program, I need to have some data and an algorithm. So I will pass this input data to algorithm and see what is the output. So input data and output data are the data, and the way you are solving the problem is solving a problem in finite number of steps. Algorithm will help you to write a program. So an algorithm is an effective procedure for solving a problem in a finite number of steps. Or you can say that algorithm is a well-defined list of steps for solving a particular problem. The problem could be anything, and you are trying to find the solution, and you are coming with a well-defined steps, list of steps, that is algorithm. Okay, is this clear?
Yes.
Yes.
Yes, sir.
Yes, sir.
Right. So there are different ways you can write algorithms. So one is step form. So a step form says that you can write the procedure in terms of written statements. You can write simple English statements. So each statement solves a part of the problem, but all the steps will give you a complete solution. So these steps are defined in a simple normal English language, or to define the procedure. Okay. So every statement will define some action which are logically related to the previous statement. Okay. So for example, I want to make a pot of tea. I want to make a pot of tea. So step one, what I'll do, if the kettle, I'll see the kettle, if it has no water, I'll fill the kettle. Step two, I'll plug the kettle into the power point and I'll switch it on. Step three, I'll see that if teapot is not empty, then I'll empty the teapot. Then fourth, I will place the tea leaves in the teapot. Then five, if the water in the kettle is not boiling, then I'll wait till it boils. Okay, so I'll stay in step 5 only till the water boils. Then once the water is boiled, I'll switch off the kettle, I'll turn off the switch, then I'll put the hot water into the teapot, will give me the tea, right? So these are the steps, each step, there are 7 steps I'm defining to solve a problem of how to make a pot of tea. Does this make sense?
Yes, sir.
Right, so you are defining step 1, step 2. Step 1 you do this. After step 1 you do the step 2. After step 2 you do the step 3. Step 4, step 5. So you have 7 steps. So this is a set of well-defined statements or well-defined list of steps to solve a problem in a finite number of steps. In a finite number, you have only 7 steps to make the T. You follow this simple procedure, you will get a T. Okay, so this is how we are defining this simple step form. So in terms of written statements, the second way how you can state your algorithm is using flowchart. You can define your algorithm, the sequence, how the set of steps in terms of flowchart also. So flowchart uses symbols, a language represents sequence, decisions, and repetition actions. For example, I want to find what is the sum of first 50 natural numbers. So when I want to define what is the sum of 50 first natural numbers, so in flowchart you will use start and stop with an ellipse. You will use ellipse symbols. Then you define your input data in terms of any statements that you are writing. You will write in a rectangle box. You start initialize some value as 0. You take n value as 0. Then you are applying some operation. N will increment. Now n value will become 1. Some value is 0 here, then you are writing sum is equal to sum plus n, the sum value will become 1. Now you are checking is n value is 50. So this is a decision, a rhombus box you are using to make a decision. So you are checking if the n value what you are incremented here is 50 or not, because your objective is, your problem is to find the first 50 natural numbers only. So this is your problem. So you are finding the solution by designing a sequence set of steps and using flowchart. So if it is not 50, then no, then you are making a decision here whether to go to no or yes. If this value is yes, you will go here. If the value is no, then you will again go here. Then again from here you will start n is equal to 2. Sum is 1. Now 1 plus 2. Now sum will be 3. You will check n value is 2 is equal to 50. No, you will keep repeating this until n value will become 50. Then your sum will have the 50. If n value will become 50, yes, then you print the sum. Then you will have in the sum 50 times you run this loop. This is a loop which is running. You run this loop 50 times so that you will get 50 first natural number, sum of 50 natural numbers. You will print that value, you stop after that. So when you're defining your solving the finite number of steps in terms of a flow chart, this is one way you can state your algorithm. Perhaps you would have used how to write a flow chart in your first year C programming language. Is it correct? Have you used flow chart in your first year?
Yes, sir. Yes, sir. Sir, that diamonds and rhombus, right? That one. Yes, sir.
Right. So rhombus you will use to make a decision. Parallelogram you will use for input, output. So remaining statements you will write in a rectangle. You will have an arrow marks. You will use start and stop symbol using ellipse. Not eclipse, ellipse. Okay.
So when you are defining your steps using the symbols and a simple language, decisions and repeated actions, we'll say that is a flow chart. Then the third way, what we are going to write, represent, state the algorithm is a pseudocode. A pseudocode is a written form of representation of the algorithm. Okay, so it differs from the step form, but in pseudocode we will use a restricted vocabulary. So in step form we will write complete sentence written in English language, but here we will use only few words, few English words. For example, print, input, if. Okay, then only few limited restricted vocabulary to define some action for solving a problem we will use. So one problem with the human language is it is not perfect. Human language will give a lot of confusion. Okay, but the pseudocode which is in human language will help you to more accurate. Precision means more accurately with limited vocabulary we will try to define our pseudocode. For example, I want to find a maximum 3 numbers. I'm not writing complete sentences, but I'm using simple only few words to make my solution understandable. Okay, so I will start. I will ask print, so enter 3 numbers. So I will take input ABC from 3 numbers. So initially I'll assume A as a maximum value, then I'll compare with B is maximum, then I will say that then B is maximum than A, or else if C is maximum, then I will say that C is a maximum value, I'll print the maximum. So I will stop. These are the only 8 steps to find the maximum of 3 numbers. Will this logic work? If A value is bigger, than B and C, this both conditions will fail. So A will print. If A is bigger, then B greater than max will fail, C greater than max will fail. So maximum value will be A only. If B is bigger, then this condition will become true. B is bigger than A, then this condition will become true. This condition will become false. Then maximum value will print B only. If C is bigger, then this condition will fail. This condition will false. This condition will fail. This condition will be true. C will be greater than maximum. So C will print. So for all 3 values, this will print the maximum value. You can verify once. Is this logic works?
Yes, sir.
So writing in this way, in steps with limited vocabulary with few symbols, like when I say arrow, left arrow, so A is storing in maximum. A value, whatever A value is stored in maximum value. When I'm using comparing, or here also left arrows, you can say that the values are stored towards the left. So we'll define how an algorithm will work. So when I'm trying to express an algorithm for a given operation, we will assume different control structures and notations. So usually I will try to define how I'll write a pseudocode like this. So I'll define what is my algorithm does, what is the operation that it does, what are the input parameters, what are the output parameters. So my input says that these are the specific input for the operation. My output says that these are the specification of output after the successful performance of the operation. I will define the data structures. I will define my steps like this. Step 1, do this. Step 2, if I want to verify a condition, if this condition is true, then you follow 1, 2. If this condition is fail, then go to else here, then you do 1, 2, and you finish the end the F here. Then follow some more steps. If there is a while condition, then if this condition is true, then continue to do here step 1, step 2, and so on and so forth. If this condition fails, then end while. Then you define other few number of steps, then you will stop. So you'll use a simple vocabulary and try to represent what is your procedure of solving a problem in this way. This is also one of the stating way of algorithm. We call this as a pseudocode. Is this clear?
Yes, sir.
So in the upcoming classes, I will not restrict myself to a particular programming language. So when we discuss like what are the algorithm for this data structure, when I want to find a node or a search or what is my, we will define what is our problem, and we will try to find a solution in terms of sequence of steps. Most of the times the best representation is pseudocode. We are going to I'm going to give the, we are going to discuss the solution in class, in theory class, in terms of pseudocode only. Okay, when you understand the pseudocode, you can implement in any C language or any Java programming or C programming, any programming language you can able to easily implement it. Okay, so the rest of the class in the subsequent, we are going to discuss our, we'll try to see what is our problem, we'll try to see what is the solution, and the solutions we will discuss in terms of pseudocode. That is the best way representation. You see any textbook of data structures and standard data structures in some by Samantha or algorithms by Corman. You refer cryptography and network security by Forozon. You see any standard books, they define the algorithms in terms of pseudocode. There is easily understandable way with limited vocabulary to avoid confusion, and also it will make more sense. Is this clear?
Yes, sir.
Yes, sir.
Okay. Given a problem, there are many ways to find the solution. So one problem, the solutions might be many solutions. Okay, there is no only one solution for a given problem. There could be many possible solutions. So when you have many possible solutions, how do you define which solution is the best?
So time and space. How much time and space are they consuming?
Right. So you can find a solution for a given problem, but which solution is best is what we are going to study in the next class. So there are complexities, time complexity and the space complexity, that will help us to determine how to verify which algorithm is efficient. Okay, that we will study in the next class on Thursday's class, because once I start now, we'll be not able to finish because it's already 12:48. So we will discuss how to calculate time complexity, what are the standard ways, what are the various ways, what is the best way that we can learn. We will all try to understand on Thursday class how to calculate the time complexity, okay, to define which algorithm is running best. So that will help us to understand in the upcoming class when we define some solution, what is the complexity when we discuss, that will help you to say that this is the complexity, okay, so can we improve it, or can we decrease the complexity, or can we find some other better solutions for the existing solution. All these things we will discuss in the that will help us to understand in the subsequent classes. Okay, so we will stop here. If you have any doubts so far, you please ask. Otherwise, you can see in your team, MS Teams, I already uploaded this slide in your team. You can verify it. We will be able to see introduction to data structures and algorithms. Lecture 5, introduction to data structures. You can verify in your classroom. Class materials.
Yes, sir, we can see it.
So go through the slides.
Yes, sir.
If you have any doubts, you can ask me in the next class also. Or if you have any doubts you want to ask right now also, you can ask. I will give a couple of minutes.
Sir,
Yes.
sir, I have a doubt from last class. Sir, you gave that assignment to find the difference between I3, I5, and I7.
Yes.
Sir, there are a lot of generations, and each generation have a lot of models. So how do we have to differentiate them?
So you have to find all the what are the available generations are there, and you find what is the difference among them.
Sir, among all models of each
Yes, all models,
generation.
all generation, all models.
Okay, sir.
Okay. See, if you are finding only one generation, your assignment will not take more than 5 minutes.
So there are 11 generation, and sir, models were around 18.
I know.
18.
I know. Explore all of them. Try to understand the difference. That's what the assignment is. You have to explore all models, all generations. Is this clear?
Yes, sir.
And sir, when we install an OS in a PC, sir.
Have you tried it? Have you installed it? It's up to you guys. It's not a mandatory. You don't. I mean, like if you have an experience that's good, you try to do it. There is no time limit for that. You can do it anytime you want. And if you are facing any issue during that time, you can let me know. Or I am sitting in my cabin only. If you want to come in front of me and do it also, if any issues are there, I can help you. You can do it that as well.
Thank you, sir.
Okay, if there are no doubts, we will stop here. We'll continue from Thursday's class.